What's up guys, welcome back to another video here at Achieve Academy, and today we'll be going through simultaneous equations. Please like and subscribe if you haven't already, because I promise you, it is this easy. Our learning outcomes for today is to understand how simultaneous equations work and understand the ways of working them out, and also to solve simultaneous equation exam questions. So, what are simultaneous equations? Simultaneous equations are two or more algebraic equations that can be solved at the same time. Linear simultaneous equations with two unknown variables can be solved via three methods: graphical, elimination, or substitution. In this lesson, we will focus on solving linear simultaneous equation exam questions by using elimination and substitution. Graphical will be its own video, which will be next. First, let's have a look at solving simultaneous equations via substitution. When we have simultaneous equations, we can rearrange one of the equations to substitute into the other. So here, when we have 3x plus 2y equals 56, and 3y minus x equals 7, here we can rearrange the second equation to find x on its own, which gives us 3y minus 7 equals x. Now, we can sub x into the first equation, so we can find out what y equals, and then we sub y into our other equation to get what x equals. So, if we sub x into our first equation, we do 3 bracket 3y minus 7 bracket plus 2y equals 56. And if we expand the bracket, we get 9y minus 21 plus 2y equals 56. Now, if we plus 21 to the other side, and we plus the 2y to the 9y, we get 11y equals 77, giving us y equals 7. Now, as we know the value for y, we can sub it in to any of the equations. We could do the first equation or the second equation. I've done the second equation because it gives us x on its own. So, we do 3 bracket 7 minus x equals 7, meaning 21 minus x equals 7, giving us x equals 14. Substitution works the best when you don't have variables which are the same. For example, if both equations didn't have 3x. Substitution is also used when you have quadratic simultaneous equations which are a grade 8 or 9 skill. The other method of working out simultaneous equations is the elimination method. In the elimination method, one variable is eliminated by adding or subtracting the equations. This leaves one equation with one variable. So here, x plus 4y equals 6 and x plus 3y equals 4. As both x's are the same, we do the same sign subtract, because both x's are positive. So we do 4y minus 3y, and we do 6 minus 4, getting us to y equals 2. And then we can sub it back into these equations to find what x equals. And then in our other one, x plus 2y equals 6, and 3x minus 2y equals 10. The different signs mean we add, because we're getting it to 0. Because we have x and x, the way we get to 0 is minusing the x. But we have 2y minus 2y, we've got to add. So we do x plus 3x equals 6 plus 10, giving us 4x equals 16. And then we can simplify that down to x equals 4. Always use the elimination method if you've got variables which are the same. If you've got two sets, say of 3y, use the elimination method. If you don't, probably use the substitution, because it will be easier. Once again, it's that time to have a go at some Maths Genie exam questions. Have a go, pause the video, and unpause when you've done. So, the first question asks us to solve the simultaneous equation 4x plus 3y equals 18 and x minus 3y equals 7. As we have the same variable of 3y here, we're going to use the elimination method. So, as it's different signs, we add. So we do 4x plus x and 18 plus 7, get 5x equals 25, meaning x equals 5. Now, we sub x back into the equation, so we do 4 bracket 5 plus 3y equals 18. If you want, you could have done the second equation, they both work the same way. So here we then get 20 plus 3y equals 18, meaning 3y equals minus 2, meaning y equals minus 2 divided by 3. So we then write x equals 5 and y equals negative 2/3. Now in our second question, we have to solve the simultaneous equation of x minus 3y equals minus 23 and 5x plus 2y equals 4. Now, as we don't have a common variable, we're going to use the substitution method. So we get x on its own, which is 3y minus 23, and then we sub that into our other equation. So we do 5 bracket 3y minus 23 bracket plus 2y equals 4, giving us 15y minus 115 plus 2y equals 4. And then if we plus 115 to the other side and we do 15y plus 2y, we get 17y equals 119. And you can use your calculator, divide that by 19, and you get y equals 7. Now we sub that back into our other equation to get x. So we do x equals 3 bracket 7 minus 23. Giving x equals 21 minus 23, meaning x equals negative 2. So our value for x is negative 2, and our value for y is 7. Just to reiterate what we're on about before, the key with simultaneous equations is understanding when to use what method to work out the question. This is because you have a limited amount of time in your exam, and you don't want to waste that time. If there's a common factor in your equation which you can divide by, do so and substitute it in. If there's a variable just on its own, such as x or y, use substitution. However, if the variables are the same, use elimination. You can also get asked about real-life examples of simultaneous equations, such as the price of coffee and tea, or big or small bags of sweets. If you deal with big or small questions, make sure the value of big is bigger than small. This may seem common sense and stupid, but this is a common mistake when you get to writing your values on the answer line. I've seen so many people get the right answer and then put the value for the big sweets on the small sweets, and then you just lose your marks because you wrote your answer on the answer line, meaning you'll lose marks because that's what you've said is right when it's wrong, even though you've worked it out right in the question. And it's a silly way to lose marks when you've done the whole question right. Here are some more exam questions for you to have a go. Have a go, pause the video, and unpause when you've done. So, in our first question, we are asked to solve the simultaneous equations of 3x equals 9 plus y and x plus 5y equals 5. As we have no common variable, we're going to rearrange one of the equations and sub it in. So, we rearrange to get 3x minus 9 equals y, to get x plus 5 bracket 3x minus 9 equals 5, giving us x plus 15x minus 45 equals 5, plus 45 to one side and plus the x of 15x, and we get 16x equals 50, giving us x equals 25 divided by 8. Now, if we sub our value for x into our other equation, we get 3 bracket 25 over 8 minus 9 equals y. 3 times 25 over 8 gets us 75 over 8, and 9 can be rewritten as 72 over 8. So we do 75 over 8 minus 72 over 8 equals 3 over 8, and that is our value for y. So our value for x is 25 over 8, and our value for y is 3 over 8. So in our second question, we're asked to solve the simultaneous equations of 3y plus 11 equals 4x and 10x plus 2y plus 1 equals 0. First, let's move our numerators to one side so it makes it easier. So we rearrange to get 3y minus 4x equals minus 11 and 10x plus 2y equals minus 1. Now, if we were to substitute in, because we don't have any common variables here, if we were to substitute it in, we'd have to divide y or divide x either by 3 or 4, and then we'd have minus 11 over 3 or minus 11 over 4. This wouldn't be very nice to work out, say if this were on a non-calculator paper. But we can make our own common variable here. We can either times 10x and 4x to get them to a common variable. We can times 3y and 2y to get a common variable. So a common variable of 3y and 2y is 6y. This, if we times 2y by 3, we get 6y. If we times 3y by 2, we get 6y. So, this is what we do. So we get 6y minus 2x. You've got to times the whole equation by 2 and the whole second equation by 3 in this instance. So we get 6y minus 8x equals minus 22. And 30x plus 6y equals minus 3. Now, as the 6y's are both positive, we do the same sign subtract. So we get minus 38x equals minus 19. So you do minus 22 minus 3, which is minus 22 plus 3. Now, as they're both negative, we flip it to give them positive. So we do 38x equals 19, because they're both the same. Now, we divide 19 by 38 to get x on its own, get an x equals a half. Now, we substitute half back into our equation. Any equation if you want, I've used the second equation. So we do 10, bracket a half, plus 2y plus 1 equals 0. So we get 5 plus 2y plus 1 equals 0, 6 plus 2y equals 0, divide by 2, 3 plus y equals 0, meaning y equals minus 3. So our answer for x is a half, and our answer for y is minus 3. Now it's time to have a go at some of the harder exam questions you'll probably be asked on simultaneous equations at a grade 5 level. Have a go, pause the video, and unpause when you've done. So, in our first question, in a shop, 2 coffees and 3 cakes cost £9.95. In the same shop, 1 coffee and 4 cakes cost £10.35. Work out the price for 1 coffee and the price for 1 cake. So here we give coffee and cake variables such as x and y, and it equals the cost. So 2x, coffee is given x and cake is y. So 2x plus 3y equals 9.95. In our second equation, x plus 4y equals 10.35. We rearrange our second equation to get x on its own to get x equals 10.35 minus 4y. Now we sub x into our first equation. So we do 2 times the bracket of 10.35 minus 4y plus 3y equals 9.95, which gets us to 20.7 minus 8y plus 3y equals 9.95. And if we simplify this all down, we get minus 5y equals minus 10.75. This is the same as 5y equals 10.75. Divide by 5 to get y on its own, which equals 2.15. Now, we substitute this back in to our other equation. So we do x plus 4 times the bracket of 2.15 equals 10.35. So x plus 8.6 equals 10.35 minus 8.6, and we get x on its own given 1.75. Remember, coffees is x and cakes is y, so the price of a coffee is 1.75 and the price of a cake is 2.15. Now with our second question, sweets are sold in small packs and big packs. There is a total of 175 sweets in 4 small packs and 3 big packs. There is a total of 154 sweets in 5 small packs and 2 big packs. Work out the number of sweets in each small pack and in each big pack. So, here I've used S and B for small and big. So we do 4S plus 3B equals 175 and 5S plus 2B equals 154. Here again, I've made a common variable as 6B, because I've times the first equation by 2 and the second equation by 3. So we have 8S plus 6B equals 350, and 15S plus 6B equals 462. Now, as it's the same type of subtract, we subtract both equations. So we do 15 minus 8 to get 7, and we do 462 minus 350 to get 112. You can do it the opposite way, you'll just get minuses, and then you just times it by negative 1 to get it positive. So we get 7s equals 112, divide by 7, and we get s equals 16. Now, we substitute that back into our equation. I've used the first equation, so we do 4 times 16 plus 3b equals 175, meaning 64 plus 3b equals 175, minus 64 from both sides, giving us 3b equals 111. Divide by 3, and we get b on its own equaling 37. Remember, the big pack must be bigger, So we do our small pack, which is 16, and our big pack, which is 37. And that, ladies and gentlemen, is the end of today's lesson. And I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I will see you in the next one. Goodbye.